All right, one more time. We're still in our Bending Light PhET app, and so I wanted to make sure that we finish this up. And we've already established that as light goes from what we call more optically dense medium to a less optically dense medium, we get the angle of refraction is larger than the angle of incidence. It's bending away from the normal. Now, as we move our light along here, you're going to notice we can bend it so much that effectively I can't get to that exact point. Trying to skim the surface, can't quite get there. I don't have enough control, but it's getting there, and eventually it would just skim the surface. That would be that 90-degree angle. But if you notice, more and more light's reflected and less and less light is refracted or going into the new medium. And if we take it too far, we get what's called, there's absolutely total reflection and absolutely no refraction. Okay? This is called total internal reflection. And that angle that we get to where, there we go. Okay. That angle we go to where, just a hair, come on, let's see if I can, there we go. Nah. Let's try and oh yes, that's as good as I'm going to get on this one. Sorry about that, I'm excited. And this angle here, where the idea is that we have, ideally we want this line to be skating that surface. It's still technically, it's bending into it, but it's right along that surface. That's called the critical angle. And if we go above the critical angle, we get that total internal reflection. Below the critical angle, refraction, everything's bendy, nice and normal. As we get closer and closer to that critical angle, the bending gets more and more extreme. And then if we go over the critical angle, we get that total internal reflection. So we're going to practice mathematically with that in a second.